So today we added in a little bit extra while we were doing our parent function worksheet number 2, when we came across a couple that were a little trickier than some of the ones we took notes on. So when we did our parabola, then we did our exponential. Onto our exponential and onto our square root graph, we added a couple of ideas. So I'm just going to scroll down to underneath this. We had talked about increasing exponentials versus decreasing exponentials. We had talked about ones that had a negative in front, okay, that had been the increasing type that I colored in blue here, and ones that had been decreasing, and then a negative, this is what they look like over here. What I'm going to talk about real quick is understanding the relationship between, for example, 2 to the power x and let's say 1/2 to the power x, or 1/3 to the power x and 3 to the power x. So kind of as an example, if I was to graph y equal 2 to the power x and y equal 1/2 to the power x, they're going to be symmetric. They're going to be mirror images. And when we as a class did this, we were doing this on just our line paper. So we were not being accurate. So I'm just sketching. I'm not being accurate. And let me just kind of maybe color code these. Hold on. Let me rewrite this one in maybe pink. And let me rewrite this one in maybe green. Okay. So there we go. So when I am graphing y equal 2 to the power x, we have an asymptote on the x-axis. Let me just kind of highlight it. Let's kind of highlight it. That's going to be true for both of these graphs. So they have an asymptote at y equal 0. Okay. Now, when I'm graphing my 2 to the power x, remember 2 to the power 0, anything to the power 0 is 1. So I'm going to have a point here at 1. Now, I'm going to just kind of graph this accurately here since I have graph paper in front of me, but we did just sketch these. What's happening is if this is 1 high, this base of 2 means I'm doubling. Okay. So then my next one's going to be 2 because that's twice as high. And the next one's going to be 4 because that's twice as high, and so forth. We're going backwards. Half of 4 is 2, half of 2 is 1, half of 1 is a half, and so on. And then I'm going to have my exponential growth one. Okay, and I'm going to do this. Let me just, I'm going to move this equation. Move this equation. Let me do this. I want to write it by it. So this one here is my y equal 2 to the power x. Okay. My 1/2 to the power x. If I take 1/2 to the power 0, I get 1. Okay. If I take 1/2 to the power 1, I get a half. So what's happening is I'm taking half and so forth. But going backwards, if I'm taking half and half and half going backwards, I'm doubling going the other direction. So this is going to be 2 because half of 2 was 1. 2 is half of 4. 4 is half of 8, and so on. So this is what a 1/2 to the power x looks like. And it is a mirror image across the y-axis, sorry, of 2 to the power x. Okay, and that's going to be true for a 3 and a 1/3, or a 4 and a 1/4, and so forth. Now, another way to think about this, okay, I'm just going to copy this. Try to copy one more time. So another way to think about this, the same 2 graphs, okay, but instead of thinking of this as a 1/2 to the power x, okay, what I want us to understand is that 2 to the that's a little fat. Let me make that not so fat. 2 to the negative first is the same as 1/2. Okay. So what that means is if I raise 2 to a negative, it's going to make it into the reciprocal. It's reciprocal. Okay. A 1/2. So this 1/2 to the power x that I had in green can also be written as 2 to the negative x. Those are the same. Okay, so y equal 1/2 to the power x is the same as y equal 2 to the negative x. Those would be the same two graphs. I just want us to understand it. Okay, what the negative x does is it basically flips, just going to kind of highlight here, everything that's on this side of the x-axis, I mean of the y-axis, to this side of the y-axis. That's what that negative x does. It flips them across the y-axis. That's what we added in. We also added in for square roots the following. Okay, so we graphed a square root. Okay, we showed both of these situations, have our general equation. Now what I did down here was I added in a couple of different ideas. So I'm sketching, I'm not being accurate with this. Okay, if I was to graph y equal the square root of x, okay, y equal the square root of x, and I'm just going to sketch this. I would have a a starting point at 0, 0. And then what happens is this graph is going to go to the right. And I'll just kind of show us why, but again, we just sketched it because the square root of 0 is 0. That's why I have 0, 0. The square root of 1 is 1. The square root of 1, 2, 3, 4 is 2, and so forth. And so that is what that graph looks like. Now, we're also going to have another graph where if I was to make my x negative, and so I was to have y equal the square root of a negative x, and I'm just going to move this over a little bit. Okay. What's going to happen is I am going to have 0, 0 still. Just going to move this down a little. I am going to have 0, 0 still because the square root of a negative 0 is still going to be 0. But what's going to happen is I cannot put in positive numbers because if I put in a positive 1, I get the square root of a negative 1. If I put in a positive 2, I would have a negative square root of a negative 2. That's not possible. But if I was to put in a negative 1, that would actually end up giving me a positive 1. And if I was to put in a negative 2, that would actually end up giving me a positive 2. So what's going to happen is the graph's going to go to the left. So I'm going to have a point here because the negative 1, if I put a negative 1 in there, I would have ended up with the square root of 1. If I went to left 1, 2, 3, 4, that would have given me a 2 back. So that's going to make this graph go to the left. Now, if I put a negative in front of either of these situations, so let's say that this one here, which was a square root of x, let's say I put a negative in front of that. What's going to happen is I am going to end up, let's graph this. I'm going to end up with the same graph as the one above, but and it's going to open to the right, but instead of going up, it's going to go down. And that's going to be my graph. Now, if I have y is equal to, and I have a negative square root, that's going to make it flip to the left, but putting a negative in front of that makes it flip down and to the left, okay? So in this case, I have 0, 0 here. And again, it would have gone to the left, but now it's going to go to the left and down. And that's my graph. So a positive square root of x goes to the right. If I have a negative in front of the x, okay, underneath my square root, that makes it go to the left. A negative outside is going to flip it. So for this one right here, it's going to flip it. So it's going to be flip down and go to the right. This one here, this negative in the x is going to move it to the left. This negative here is going to make it go down. So we talked about that and added that in before we did our worksheet. Okay. So hopefully that will help you with some of the ideas we did in class over notes.